Okay, in this video, we're going to start talking about graphing when y equals ax squared plus c. This one's a little different than the last because we have the plus c. And what that plus c does, if you remember, is it moves our graph up or down. So when we have, for example, on this first one, a plus 3, we know it's going to move our graph up 3. And if we have a plus 5, it's going to move our graph up 5. So when we go to graph these, instead of having a vertex that starts at 0, 0, this one is going to start at 0, comma, and then we know it's moved up 3, so it's going to start at 0, comma, 3. We're going to plug in the same numbers we've been using, 1, 2, -1, and -2. There's some extra spots there. If you want to plot more points, you can. We're going to plug these x values right into the equation. Again, we're going to do the x squared first. So -2 squared is 4. And then we're going to add 3. So 4 plus 3 is 7. Then we're going to do -1. -1 squared is 1. Plus 3 is 4. And then 1 squared is 1. Plus 3 is 4. 2 squared is 4. Plus 3 is 7. Now you'll notice all of our y values are positive, and on this one, since we need to put our own x and y axis in, that's important for us to pay attention to. All of those values are positive. So we can start by putting our x-axis down here towards the bottom and put our y-axis kind of in the middle. And then we'll plot our points. Our vertex is at 0, 3. So we're going to go over 0 and up 3. We have the point -2, 7, so left 2 and up 7. -1, 4, so left 1, up 4. +1, 4, so right 1 and up 4. And +2, 7, over 2 and up 7. We'll just sketch our graph there. For this one, our vertex we see is at 0, 3, and our axis of symmetry, it still goes straight through the middle there since it's only moved up, so it's still at x equals 0. The domain is all real numbers because we're still talking about a quadratic even though we've moved it up 3. The range now, when we look for the lowest point is right here where y equals 3. So the range is y is greater than or equal to 3. This graph is increasing on the right-hand side. So we're going to say it's increasing where x is. Let's see. It's increasing where x is greater than 0, and it's decreasing where x is less than 0. Well, let's see. It was writing a second ago, and now it's decided not to write again. Let's see. It's increasing, there we go, where x is greater than 0. It's decreasing where x is less than 0. Okay, for this one, we have y equals -2x squared plus 5. So that plus 5 means it's moved up 5. So we're going to put our vertex at 0, 5. That's our vertex. Since x is still 0, our axis of symmetry is going to be at x equals 0. We're going to plug in the same numbers we've been using. Plug them in. We're going to do the x squared first times -2 and then plus 5. So we'll do -2 times -2 squared plus 5. So that will give us 4 times -2 is -8 plus 5 is -3. When we plug in a -1, we get -1 squared is 1 times -2 is -2 plus 5 is +3, and then we know that these are going to be the reflection, so we're going to go ahead and stick those there. Now if we look at these x and y values, we see that we have positive and negative values for y. So I'm going to move my axis, x-axis, kind of back a little bit higher so we have plenty of space to graph all of those. We'll plot the vertex first at 0, 5. And then we have the point -2, -3, -1, +3, 1, 3, and 2, -3. So we see this one is a vertical stretch because it has the 2. It's a reflection in the x-axis because it's a -2. And it's a vertical translation up 5. All right. We're going to skip over the domain and range for this one. We've done that several times because I'd like to get to one more example here. We have y equals 1/2 x squared minus 4. On this one, I gave you some space here in the table to do some work if you wanted to do work. But since this has a -4, we know that the vertex is at 0, -4, because that -4 moves us down 4. And then we're going to plug in our values. So this would be 1/2 times -2 squared and then -4. So -2 squared is 4, times 1/2 is 2, and 2 minus 4 is -2. We'll do the same thing with 1. That's going to give us -3.5. And then using the reflection, I'm just going to go ahead and write those down on the other side. All right, all of our y values for this one are negative. So I'm going to move my x-axis up towards the top. We said our vertex is at 0, 4, or sorry, 0, -4, so our vertex is down here. And then we have the point -2, -2, -1, -3.5, 1, 3.5, and 2, -2. So here we have a vertical shrink by a factor of 1/2, and we have a vertical translation down 4. Our vertex was at 0, 4, and our axis of symmetry was still at x equals 0. Our range for this one, since we have a lowest point where y is equal to -4, our range is y is greater than or equal to -4, with our domain still being all real numbers. Okay, let's sum up this part. How does the value of A affect the graph? Well, we know that the value of A tells us whether or not it's a shrink or a stretch. So it's going to tell us if it's a shrink or a stretch. And it's going to tell us if it's a reflection or not. So whether or not it opens up or opens down. Oops. It hasn't changed because of the plus C. It still tells us the very same thing. How does a positive value of C affect our graph? That gives us a vertical translation up, whatever the value of C is. If it's a negative value of C, we know that it's going to be a vertical translation down. However many C was. Now the vertex, we know when it was ax squared, it was just at 0, 0. But the plus C has moved us up or down. So our vertex is now going to be at 0, however much we moved up and down. So our vertex is going to be at 0, C. Let's put some space in there so we can read that a little better. But the axis of symmetry for all of these was still at x equals 0 because it hadn't moved to the left or to the right. So in this video we talked about how to graph y equals ax squared plus c. We said the c tells us how far we've moved up or down but we haven't moved to the left or to the right, so our vertex is still going to be somewhere on the y-axis.